All right. Thank you very much for the warm welcome.
And you're going to need it.
Yes. All right. So welcome to the hardCORE workout. It's not going to be that difficult, but yeah, you can stretch if you need to. But there's going to be a lot of material, so I'm going to go a little bit fast. But if you have any questions, feel free to just kind of stop me in the middle. There's a lot of material to get through, so I might say like hold it or find me after. But if there's anything that you think would like help your understanding, feel free to classroom style raise your hand and I'll try and address it. So without any further ado, I'll get going. So first off, you guys are all here to become a Bitcoin core developer, conceivably, or at least figure out what that means. So what is a Bitcoin core developer? So there's two things that make you a Bitcoin core developer. You're either a contributor, which means that you're going to be writing code and suggesting that the reference client should include it. You might be writing tests, and you might also be reviewing and commenting on other PRs, or doing general research and analysis on protocol changes. Then you could be a maintainer. So a maintainer would be somebody like Vladimir, who's the lead maintainer. And this means that you have commit access, and you look at all the work everyone's doing, and you decide which things actually get included into the reference client. It's actually, people often think that being a maintainer is like a big honor, and everybody aspires to be a maintainer, but actually most people don't want to be a maintainer. It's a somewhat janitorial role. And there's a big responsibility of having the keys for signing, code that gets accepted by everyone. So it's a liability for a lot of people. So somebody like, Greg Maxwell said, I'm not that active anymore, and so he gave up his keys. Gavin, his keys were also removed at some point because he wasn't committing anymore. So it's not really just like a extra role. But most people are Bitcoin core contributors. But if you're either one, you're a core developer. So that's like a really strict definition. I just told you like the most boring thing. It's just somebody who writes code. But there's more generally, it's kind of like, well, what's a professor? We know that a professor is somebody who teaches classes at a university, and that's the strict definition. If you do that, you're a professor. But when we say professor, we generally mean you're somebody with a distinguished research career, and you do research. And actually, at most universities, they say the best people to teach are people who don't want to teach and just want to do research, because they're going to be very efficient at their teaching, or really bad at it. So it's kind of similar to how like a core dev is a coder. That is something that core developers do, but generally they're known, and it's kind of a esteemed position because they introduce a lot of influential ideas to the community, and serve kind of a very responsible role in discourse and dialogue. You don't need to be a core dev to do that. There are a lot of other people who don't actually contribute code who do contribute lots of high quality and interesting ideas. But it's just a general, kind of distinguished thing that, if you can write code for the reference client, you're considered, to surpass some threshold. And lastly, it doesn't necessarily mean that because you're a core developer, there's any endorsement or any sort of like smart thing that you're going to say. Core devs oftentimes say like pretty stupid things, as I'm sure I'll say something stupid today. So it doesn't necessarily mean that they understand it better than anyone else. So in this talk, I'm going to have kind of three major sections. Now that we at least have some sort of idea of what it is we're trying to figure out, we're going to talk about the Bitcoin development process. We're going to talk about Bitcoin improvement proposals, and then we're going to talk about a little bit of Bitcoin performance engineering, which is, I think, an approachable topic for getting started. So first, the intro to Bitcoin core development. So there are a couple things to go over. There's foundations. There's your development environment, what you do when you want to start coding in Bitcoin, how you contribute, so like what style you should go with, and like how you engage with other people, and then some just general advice for surviving in the space. So for your foundations, it's really critical to understand the philosophy of Bitcoin core contributors. Now, just because this is the philosophy of people there right now doesn't mean this needs to be the philosophy forever, because when you come and contribute to the community, you have your own philosophy that you bring to the table. But in general, most people share these perspectives, which are that you want to respect all different kinds of Bitcoin users. You say, well, for my use case, I'm an exchange, or I'm a miner, or I am just a user. You go, my use case is valid, but yours is too. Everybody, you're writing software for everyone, not just for your own use case. that said, you have to scratch your own itch. If there's a feature you want, you can't just bang your fist on the table and say, make this happen for me. You have to write the code yourself. So if there's something that you really need, you need to be your own advocate for that. And if there's something that somebody else needs and they're not a developer, it can be your job as well to be empathetic and hear that somebody else is asking for something and pick it up for them if they don't have the skills themselves to do it. Bitcoin use in general, people think of it as free speech. So anything that is trying to tell somebody else how they should use the protocol is in some sense frowned upon, and there are exceptions to that. Slow and steady is good. This is security critical software. Your own ego is much less important than Bitcoin progressing and being secure. So even though you may have done a lot of work, if it's not up to the quality standards of Bitcoin, it's not going in. And that can sometimes be personally difficult to navigate for almost everyone. And just lastly, that not everyone has the same goals for the project. Some people have a really long-term view that, hey, Bitcoin is going to be driving payments for everything. Other people really feel Bitcoin is going to be the reserve currency. Other people think smart contracts are the best thing. And we all have to kind of find a way of using the common platform together and coexisting. So you have to keep in mind when you're talking with somebody that they may have a very different end goal for the technology. So for communications, there is a lot of material that exists online. So if you want to go and ask somebody a specific question because you think that they would be able to find it faster than you, ask them. But for most things, you can find it by searching, and it's been talked about before, maybe in IRC, maybe on the mailing lists. And if you just go and bombard people with questions, which often happens, you will really sometimes annoy them. Some people are very patient. I know that Greg Maxwell will endlessly tell you why you're wrong about something. And it's great, and a lot of people have used that as a resource to be able to learn really intricate things about the protocol. But you have to keep in mind that that's not what they're trying to do all day. They have other things that they want to do. So doing a lot of research is good because there's a lot of material. Organizationally, it's not great, but there are people like Kanzure, Kanzure, Brian Bishop, who have put together really excellent archives of a lot of the information and transcripts from talks. You can look at the scalingbitcoin.org website, and there's transcripts and video recordings of all the talks people have been giving over the last few years. So the information is out there. It's a little bit of your job to do it. Lastly, because people do use IRC, if you want to talk to people there, that can be the best place to talk. But you have to keep in mind that it's a single-threaded conversation, so it's a little bit like jumping into somebody's tweet stream and then tweeting in the middle with a completely unrelated question. If people are talking about something, be respectful and kind of wait your turn and don't demand answers. So yeah, the main channels, there's a Bitcoin Core Slack that you can check out. There are these IRC channels that get used. The GitHub issues are good to follow as well. And then there are some Linux Foundation mailing lists that get used for kind of announcement-related things. And if you have a big proposal or a new version comes out. And then there's also a Stack Exchange. And the Stack Exchange is probably the best place to go and ask questions for understanding of something that you don't think is a new research question. I personally would recommend that you first join the Bitcoin Core Slack. If you join that has mirrors of all the IRC channels, so you will be able to be a listener and see what people are talking about for a while, but you won't be able to post. But everybody else is typically around there, so you can still ask them questions if you want to. And it's a little bit, I don't know, I guess IRC is a little bit hard to use for some people, myself included. I don't like IRC that much, so I don't hang out there. But everybody does their own thing. Lastly, GitHub. It's important to understand that this is really for code, not for discussion of ideas or anything. That is not directly code related. So a lot of people will show up and say, hey, I have this new idea for some crypto primitive, and they'll post it in GitHub, or they'll say, hey, you know what, Bitcoin should really do this, over the next 10 years. And that's not really what happens on GitHub. The types of things you talk about there would be this module can be improved by doing X. So that's kind of the focus of that. The other channels are better for more hypothetical exploration. So your development environment, what tools do you need to actually get started? Does anyone have any questions, by the way, about the last section of kind of foundations? Good. Okay. So development environment. So pretty simple. Oh, yep. Totally. Yeah. And most of this, I think this is recorded, but there's also recordings of, like, I presented some of these slides previously, so you can also find those as well. So it's pretty simple. You fork it, so you make your own, version if you want to, like, have, like, local branches. You clone it, and then, you just start doing development. I'm guessing everyone here is familiar with how Git works. If not, there's a lot of great material online explaining it, or at least explaining how to, like, unmess up your repository after you've messed it up. So to run a Bitcoin node, after you've run your build commands by following the build instructions, there's some dependencies that you have to make sure that you get right, but the instructions are all there. I recommend, if you don't have, like, a recent Ubuntu desktop software running, just, like, use, like, a Docker instance or a VM of some kind, or an Amazon server, because you don't want to spend too much time futzing around with, like, a Windows build or something. If Nicholas Dorier is watching, he'll tell me Windows is the best, but you don't want to add extra complexity when you're just getting started. Build it. The first build is going to be really slow because it does an incremental build, so it's going to take, like, maybe an hour depending on what your computer is, and if you've built some of the dependencies before. But you'll get through that, and then it's going to be a lot faster to rebuild. So after you've built it, now you can run bitcoind, and you can run one with debugging information being output. You can run one on the test net. You can run one in a regression testing mode. This is now your playground, and there's a lot of information online about, like, what you can actually do once you're running a Bitcoin node. If you run one that's just, like, plain ./bitcoind on your computer, it might not be the best experience, because you're going to have to synchronize the entire blockchain, which could take a couple hours depending on your network connection and which computer you're running it on. So you probably want to, if you're just experimenting, run it with the regression testing mode, which isn't going to do any work and is going to let you do fun things like make as many Bitcoin as you want for yourself. Definitely, it's fun to like open up the Bitcoin wallet in reg test mode and see, like, I have 10,000 Bitcoin. I'm can now retire. So as you start exploring the code base, one of the most important tools that I find that a lot of developers actually don't use is something called ctags. Ctags essentially compiles a list of locations for names in your code base, and then when you're in your favorite text editor, Emacs or Vim or Atom or whatever, there's a special set of like keyboard shortcuts that will let you jump to where something is defined in the code. And for getting into the code base originally, something like ctags is really helpful, because what you should do is you should read a line and say, hey, do I actually know what this object is that's being created? No. And then go use the ctag symbol to jump and read the definition of whatever that is. And as you explore through like kind of this depth first search of the code, you're going to get a really good understanding of like what's actually going on. If you don't do that, there's a lot of things that I think you're going to miss about how the things are actually made. It's not it's C++ is easy to read sometimes, but it's very difficult to write. So as you like look at how more of it is actually written in some of the more like nuanced classes, I think you'll get a better understanding of like what types of practices are used in Bitcoin. Okay, so as you begin to code, so the best way to get started is to like find a really bad idea and then just do it. It doesn't really matter what it is. Pick something that's maybe too ambitious. Pick something that you think is going to be fun, and just try it out. So one of the first projects that I did when I was programming in Bitcoin was I said, hey, there's a database, and in that database, none of the accesses are randomized. So if some attacker were to figure out like a bad access pattern for that database, they would be able to make the entire network go down. So what I did is I said, well, what I can do is I can encrypt every entry. Hashing, I don't think actually works for this case, but you can encrypt every entry, which has the effect of randomizing the order of all the databases, which means that any attacker who is trying to do a network-wide attack won't be able to trigger it on more than like their own node. So I felt pretty good about this. I thought it was a cool idea. So I asked a developer, Peter Wheel, SIPA, for some feedback, and he's like, well, that's kind of a terrible idea, because eventually we're going to want this to be in a well-defined order. We don't need it right now, so you could do it, but it's going to limit what we can do in the future. And this is something that you're going to hear a lot as you explore is, oh, this is technically fine, but we want to do something later on, and this is going to interfere with this future goal. It also wasn't sufficiently justified because even though I was able to say, well, in theory, if somebody did have an attack on a database, what I really needed to do was I needed to show an attack on a database that was relying on this bad access pattern across the network. And because I wasn't able to do that, there was not sufficient justification for the code I was working on. But the good thing is I learned a lot by doing this. I went into kind of like the internals of how the block structures and the transactions are, blobbed in and out of the database, and I learned a lot about how Bitcoin manages those things. And then I said, well, I'm going to throw it away and move on to something else. So this is what I recommend you do for your first thing. If you want, even try and do this yourself. Like try and do this exact same thing. It's not going to get merged, but you're going to do a small project, and you're going to learn something about how the code works. The next thing that's important is to build C++ expertise. How many of you feel like you're like C++ virtuosos? Anyone? Okay, so like 2 people. Most people, I think, don't really do that much C++, and getting to like virtuosic C++ is something that even most people in Bitcoin won't say they do, but you need to be really familiar with how it works. There's this blue book here by the person who wrote the C++. I can't really pronounce his name that well. Bjarne Stroustrup. So go and get a copy of this book on Amazon or online somewhere, and read like a chapter every day as you're exploring. Some of it's going to feel really introductory. This is because C++ is kind of like the standard language that everything is kind of modeled after in some senses. And anything you're looking at today that's an object-oriented system is going to really look similar. So you're going to be reading, you're going to go, okay, this is easy. I understand what's going on. But there's a lot of nuance, and you'll find that when you actually go to write something, it's going to be a lot much more difficult. This is true in anything. Like reading a book is easier than writing a book. But reading this guide is going to give you a lot of insight for why things are written the way they are, and what types of pitfalls and traps you'll run into. So get like 25 chapters into this book, and then you just keep it on your shelf as a reference. There's also a site, cppreference.com, that is a good one to use, and that will detail the exact functionality of any standard library that's used in C++. And so, yeah. Next, how many of you are familiar with GDB and have used it extensively? Again, not so many people. But this is a tool that lets you take a running program and inspect all the memory of that program and the code that's actually running if you compile it with debugging symbols. This is really cool. This lets you basically do brain surgery on your program and see exactly what's happening. So if you introduce a bug and something isn't quite working as you expect it to work, GDB is going to let you kind of add a breakpoint into that code and say, let me see exactly what the state is of the code without having to add print statements. Because sometimes you'll find bugs where you add a print statement and print statements have to lock. So they can sometimes fix concurrency bugs by adding a print statement. So if you'll sometimes find bugs where you remove the line that's printing something and then you have the bug and then you add the line back and the bug's gone. GDB will let you find some of these things as they're going on. And there are a lot of tools around GDB for inspecting running programs. The compiler can play tricks on you, so sometimes you'll see interesting things where the code that actually gets run is so heavily optimized by the C compiler that you'll be stepping through the code line by line, and then it will jump 10 lines forward and then jump 10 lines back and jump 10 lines forward, and you'll go say what's going on. Well, the compiler is allowed to do things in any valid order that is allowed by the C++ standard, so some fields might not be initialized in the order you're expecting, and that can sometimes be the source of bugs as well. So just a quick cheat sheet of things you can do. You can kind of step through your code. You can set breakpoints at various functions, and you can say, stop the world whenever we hit the specific line, and you can print out things about the variables in memory or the just raw memory if you know the addresses already. You can also look at different threads. So if you're writing a multi-threaded program, GDB is going to help you see what every single thread is working on at the moment, and this can help you if you're. There's only a couple places that are multi-threaded in Bitcoin, but it would help you with those as well. So Another thing that's really good to do as you start kind of exploring how to be productive is to review other people's code. This is actually one of the things that, like, there are certain people who only review code. They don't actually really write that much code. They just read what other people have written. It's really important, and it's going to help you get not only an understanding of like what is good code, but you're going to learn what topics people are prioritizing right now, because you're going to see what things are currently being worked on. You're going to know how people communicate feedback. Sometimes it can be like pretty aggressive. I don't think Bitcoin is quite as bad as like Linux, where Linus will tell you, get this fucking piece of shit code out of my code base, right? Like you can read like the, Linux mailing list, and he'll say that to people. It's definitely not that bad, but people will definitely be like, NAC, which means like negative acknowledgement, and that means like, get this code out of here. And if you're a new contributor and somebody like nacks you, people are pretty good about not doing that, but it still happens on occasion, and like other people will step in and be like, it's a good idea, but it's not quite what we need because like we do this other thing or whatever. Lastly, if you leave useful feedback for someone, they're going to be like pretty grateful. In a certain sense. If you like go in and you're like, I don't like the style of your code, and it's somebody who's established, they're going to be like, this is the style guide, like it doesn't really matter. But if you say like, hey, I think that like this function that you wrote could be a little bit faster if you did it this way. It's not a critique of them. It's like you're helping them improve their code, and everybody wants to improve Bitcoin. So people will be pretty welcome to that. So that's a way to like make people happy with you. And then when you go and write code, people who you've made happy are much more likely to return the favor and check out the things that you've worked on as well. So I guess if we can just take a look right now and see, this is taken like earlier today at what's going on and what people are looking at. I don't know, can you guys read that? I'll read it aloud. So these are labels for current pull requests that people are working on, or issues that they're looking at. So the top one, and these are sorted by like number of open things. So a lot of people work on wallet code. A lot of people are focused on how do we actually hold, and like manage the Bitcoin that people like are entrusting with Bitcoin Core. A lot of effort is put into the RPC library side of like, well, what utilities do we allow people who run a Bitcoin node to access? There's a lot of effort that goes into the graphical user interface. I don't personally do anything on that, but people do put a lot of energy in. People do P2P work, which is on the peer-to-peer protocol. That's how nodes connect to one another. There's features, there's refactoring, brainstorming, tests, build system, validation, docs, bug, block storage, UTXO, databases, and then resource usage. So I'm going to step through most of these with a little bit more detail, just to give you some idea of what kinds of projects people do in each of these spaces. So for the wallet, this is, as I said, the end user functionality for keeping your balances, detecting that that money has been sent to you, and making new transactions. So current things that people are working on are separating out the wallet and node processes. So Russell Ryanovsky is a developer who's working a lot on this. Right now, when you're running a Bitcoin wallet, it's actually running in the same logical process as your node, which means that like your node, if it got like hacked by one of its peers, would be able to see all the memory of your wallet, which like could have your private key in it, and that would be like patently bad. Luckily, there are measures that like help prevent this, but in general, it would be really nice if you could say none of the wallet code is like sharing anything with the node code. They're completely separate applications, and that's not the case right now. But people are working on it. SPV verification is another thing people are working on. This would let you take a Bitcoin Core node and say, here's another node that I trust. Let this one prove certain facts to me, and I'm going to believe that they're going to tell me mostly the truth, but I'm going to be able to check small statements about that. And that would allow you to say run the equivalent of a full node on your cell phone, and just connect to a semi-trusted core node that maybe your friend is running. And people are working a lot on that. There's improvements for like some of the APIs available in the wallet around accounting. In the early days of Bitcoin, there was kind of funny tool called accounts. You could say, this is my Bitcoin account for my drug money. This is my online poker money. And then what would happen, because they were actually like accounts, not UTXOs in the way we think of them in Bitcoin, you could spend money from your poker account and go into a negative balance in your drug money account. And so the whole API didn't make sense to anyone. So there's been a big effort to rename it to labels. So you can say, I got this money because of this, but it's not separate from any other fund, and make that API improved. There's multi-wallet, which is going to allow you to use multiple separate wallets. This is more like accounts as you would think of them within a single application. Right now, if you want to use a different wallet, you have to restart your node completely. This would let you load them, simultaneously. A developer, Luke Jr., is working a lot on that. And lastly, privacy. People think a lot about how you can make the transactions that you make without revealing more information about yourself than you intended to. So there's a lot of interesting stuff happening right now on that around how you pay fees, how you make change, and how you sort and order transactions. So these are all things that any of you right now could just go and jump in on and start working on. Obviously with a day or two of reading about to see what everyone is actually doing on these. So the RPC, this is also fun. I'm doing some work in this space myself. This is how you manage your Bitcoin node. This is how you tell it, hey, connect to this other node I know about. Don't connect to that one. Let me know what the most recent block you've seen is. Does this transaction exist? That's all the things you can do in RPC. It's kind of your driver's seat. And it's important if you're building applications on top of Bitcoin. So if you're building an exchange, you want lots and lots of features in the RPC that may or may not exist there right now. So you might extend them privately, or if you're going to get hired, let's say at Coinbase, they might ask you hey, add these features to us, but they might not get added to Core, or you can add them generally available for everyone. So right now I'm working on a new feature called RPC whitelists, which lets you kind of provide an authorization list for what things a specific user is allowed to do when they access your node. Other people are working on features that let you control the performance of your node, so you can tell it dynamically how many threads to run. Remote procedure call. Yeah. Sorry if that one was jargon for you guys. Yeah. So generally, it's like a JSON RPC, so you can send it a JSON saying, make a transaction to this person, and then it'll make the transaction. So it's a low-level way of interacting with your node. And also people are working on better usability. Sometimes there'll be a query that gets frequently used by an application, and it requires them to make one initial query to get some list of transactions, and then for each one of those transactions, they now need to make another RPC. And so that's what's called, and if you guys are Rails developers, it's like the N+1, they talk about that a lot, because in Rails it's really hard to not write N+1 queries, because you have to do the first one, and then you have to do N for everything it returns. So people are working on things like that are going to make it more usable for application developers. Also something that can be good to do if you go and look at some applications people have built on top, and you go, oh, they're doing one of these complicated queries where they're calling RPCs in a loop. Can we make this a single RPC? It's going to improve the performance of that person's node. I don't do any work on the graphical front. I mean, I've done one or two things, so I can't tell you that much. People, again, are working on this process isolation thing. You want to separate out the interface from the wallet, from the node. People want to expose more RPC functionality. So the RPC is power users tools, and then things get added to the graphical user interface maybe a year or two later. So people are always working on adding some of these RPC tools. And people also just work on general usability and performance. They want things to be fast and not laggy. In the peer-to-peer layer, this is again a really fruitful area for research and development. This is just a general problem space of how do we connect all these nodes together and broadcast blocks and transactions without the network going down completely. So people look a lot at things like denial of service. They say, what sequence of messages can I send to the node and cause it to fail? They also work on migrating to more reviewed standards. So we're moving right now from this custom network event library to something that's really standard called libevent. People are working on something called SPV block filters. So you can think of the peer-to-peer stuff as the RPCs between nodes. So there's the RPCs for you as for your own node that you're trying to use, but then these are things that anyone on the network or anyone in the world can ask you to do for them. So these SPV block filters would be really useful for building these lightweight wallets that I talked about earlier. There's also a lot of science going in, like, and I'm talking about science, like these are computer science papers people end up writing about how you detect bad peers and how you find good peers. Recently, there was a lot of news around this because Ethereum had a really big problem where you could, end up connected to a lot of bad peers. And they were able to fix it. But Bitcoin also, like, a lot of research gets spent on this. People also think a lot about privacy leaks. How do you prevent people from like knowing specific things about which node you are? So there's a new protocol people are working on called Dandelion, which when you send a transaction to someone, if they haven't seen it already, there's like a reasonable chance that you were the like person who created that transaction, or at least if you think about the graph, you are closer to the person who created it. So there are companies out there, Chainalysis, for example, that like make a lot of money by having lots of nodes on the network and figuring out who created a transaction. So people think a lot about how can we improve the privacy of spending Bitcoin, and one of the main things is by not leaking data about which node made the transaction. So Dandelion is something that you can Google if you're interested in those kind of problems. It works by having like a dandelion pattern. You send it to one person, they send it to another, they send it to another, and then after like a couple hops, randomly it will explode and send to every node that they know about. People also look at reducing bandwidth. It's really critical. Right now, Bitcoin, we assume that there's an internet connection. We don't have to assume that. There are ways of making the network work without an internet connection, with like a satellite connection or with other things. So people think a lot, hey, if bandwidth becomes like really, really expensive, or if there are network problems, how do we make the bandwidth as small as possible? So one of the major topics is something called compact blocks, which I'll tell you more about later if time allows, which is one of the biggest savings of bandwidth that kind of has ever happened in Bitcoin, that makes blocks propagate a lot faster throughout the network because they reduces the bandwidth of every new block found. Refactoring is something that is also pretty critical. I would say this isn't the best thing to do just coming into it for major projects, but there are definitely little things that are easy to do if you're just getting into it, because to refactor, you really have to have an understanding of like where the code is, where it's been, and where it should go. And this is something that you get as you've like seen the code base evolve for a while, of like what needs to be cleaned up. Bitcoin's like code base is not like fantastic. There's a lot of like weird stuff in it, and it like is not you wouldn't hire somebody to write a code base like that today. It turns out it's a great code base. Like it's really secure, and it's like a lot of things are really fast and like well engineered, but it's not like modular, and compile times aren't fantastic, and it uses a lot of global variables and like et cetera, et cetera. So people work on these things. They try and split modules into smaller logical units. They work on making standard libraries for some like basic functionality that like should always be the same no matter like what version of Bitcoin you're using. Like what is proof of work? What that definition is should say the same across versions. Splitting big files. So if there's a file that contains like 2,000 lines and it does two different things, and you try and split that into two different files. So one of the major ones that happened recently and is still kind of in the works is splitting the main .cpp file into two files, one called net processing and one called validation. Net processing handling all the network operations, and validation handling all the functional correctness properties. Getting rid of like libraries that are not part of the C++ standard is also a priority. So people want to get rid of something called Boost. If you're a C++ dev, you like both love and hate Boost. You want to also get rid of globals, because global variables kind of like make it harder to analyze your code, harder to test. Making like everything as explicit as possible. So I call this constifying. You could also call it like making C++ look more like Rust. If you don't need something, like if you don't need to be able to modify something, it's really good if you can like specify in the code that the thing should not be able to be modified by the person who has it. That will make it easier for you to like check that that thing doesn't get accidentally modified, or somebody introduces a bug later. Drying up code. There's a lot of things that are duplicitous in the code base, so making things a little bit tighter semantically, and reusing things that are used multiple times is good. And then also in refactoring are minus performance fixes. So if you say like, this thing is making an extra copy and I fixed it, that's a small refactoring that would get this label. Tests are also really critical. They also can be a little bit hard if you're just getting into it to do, because you have to like understand the code base. But they're also good because you have to understand the code base to write them. So there are two kinds of tests in Bitcoin. There's unit tests and there are like behavioral tests. The unit tests are testing some small piece of the code, like a single function. And the behavioral tests are saying, if we have a sea of nodes connected to one another, do they do the correct thing over time? So contributing on any of these is great. They're slow, so making them faster is something that will make everyone love you, because every single developer is spending hours a day, just waiting for their tests to come in. Adding more simulation tools is really good. It's actually a problem that there's no good utilities for simulating over historical data in Bitcoin to say, well, I think this is an improvement, but how would it handle all the data that has happened in the past? Increasing the reliability of the functional tests. Sometimes they mysteriously fail, and so it's a perpetual problem of getting them to actually making sure that the tests are themselves correct is an exercise in and of itself that you do through seeing when they fail and understanding if it's the code or the tests that are the problem. And then there are other more exotic kinds of testing that are starting to make their way into Bitcoin. Fuzzing. And more static analysis tools, and also something called property testing are becoming major topics. So I'm not giving you a laundry list of all these things, but you're going to be able to go back to these slides and kind of have the right things to Google for as you're trying to figure out what topics are exciting and fun for you. Validation, I would say, as you're getting in, noobs always come in and then want to do something in consensus, because that's the heart of it. You're not going to get anything done in consensus. Nobody gets anything done in consensus. So you might as well ignore it. It would take years to make a major change to how consensus works. So it's not a great place to start, and the semantics are really complicated. That said, take a look and see what's going on. There are opportunities for that in looking at the performance of it, looking if there are denial of service things of ways that you can make a node chew on a block for a really long time and not be able to process new information. And then there are some refactorings that are still in progress that you're able to help with as well. Lastly, the last topic that I think is really good is resource usage. This is just figuring out, hey, is my node doing something it doesn't need to do? And people are always finding things like a megabyte of memory here or there that's getting allocated that doesn't need to be allocated. And that may seem small, but people try and run Bitcoin Core on Raspberry Pis, on old ones. And if you want people to be able to do that, you need to really heavily make sure that Bitcoin isn't doing anything it doesn't have to be doing. So we're tightly looking at the resource usage is something that people do. Using custom data structures, that's something that I've done, and I'll tell you a little bit about more of a custom data structure I wrote that is a lot more optimized for Bitcoin. Even just using the correct data structure. Sometimes people use a standard map, which is a tree, when they should be using an unordered map, which is a flat array. And finding those little things can actually make a pretty big difference in critical parts of the code. And reducing memory allocations in general, looking at the operating system interactions and making sure that we're being a good citizen on the platform. There's a lot of times when if you're running a Bitcoin Core node and you're also browsing the web, all of a sudden your whole computer will lock up because it is doing some really expensive operation. So people are looking at okay, well, can we make it a little bit less aggressive and not cause disruption for somebody who's just trying to use it on their normal computer. Caching and arena allocators. There's lots of fancy performance things, and if you're definitely into the performance engineering side, resource usage is the thing that you want to look at. So does anyone have any questions about any of those topics? I know it was a lot, but we're going to be, I think, a little bit more abstract now. Yeah. Oh, so fuzzing is where you send a random noise to a node and you see if it does something. Now, when you receive a random message, unless it is actually a valid message that you were expecting of some other kind, you shouldn't do anything. Then there's more specific fuzzing, which is given a well-formed message with random data in all the fields, does it do anything? And then there's a more specific one, which is given a well-formed message with the fields correct, but the messages are in random orders, does it do anything? And so you can it's basically hitting a node with lots of garbage data that is of varying qualities of junk. And sometimes you can get surprising things to happen that you didn't know were part of the current functionality. And that's one way that you get a little bit of confidence that somebody isn't just going to accidentally take out the network. Any other questions? Okay, cool. So now I'm going to tell you about something I've been working on recently, just so you can get an idea of what this actually looks like for something people work on. So I've been working on this thing called RPC whitelists. I've been working on it for not like full time, but like it's like a side project for a couple months. So when I posted it, after like I filed an issue and I described what I wanted and I gave a proposal for what it would be, and then I added an implementation. So right away, everyone's like, this is great. So you'll see people say UTAC, that means untested ACK. That means I like your code, it looks good, I read it, but I never tried it myself. Then you see people say concept ACK. That means like, I love this idea. I have no clue if you did a good job with it. I haven't even read the code, but like, good for you for doing this. So that like is pretty weak, but it means that like, if you did well, they want this thing merged. And that's actually more important than a UTAC in some senses, because the UTAC just says the code is correct. The concept ACK sometimes means more because it carries the weight of the person saying, I like this idea in general. Then people will tag other people who they think would be relevant for that. So they'll say, you should take a look, and other stuff. Then I get somebody who goes, I don't like this at all. So he says, like, this implementation is problematic. And I didn't think it was that problematic, but he felt it was really problematic. He has good points, and this is like one of the things of like the kind of low ego that you have to have while you're doing this. Is like somebody can be like, I don't like your shit, get out of here. And you have to go like, okay, well, like, why didn't you like it, and can I make it something that you'd find appealing? So after a bit of back and forth and talking about like the general space of the thing, I updated the pull requests and I added a couple of the things that were going to make it not problematic. His main complaint was that he didn't like that when I enable the feature in order to maintain backwards compatibility. Now, that's something you're going to hear a lot of people say when you add something new is that, well, you have just added this new feature, but it needs to work the same for anybody not using this new feature. So you need to maintain backwards compatibility. Always, he said, the way that you do this actually prevents this from having a default safe behavior, and you're adding a security feature, so you should find a way to make it default to the safest possible behavior. So with a small tweak, I was able to make it default, and I think it's a good middle ground. But this is still sitting, so it's not merged yet. This is something that, if you guys wanted to tonight, you can go take a look and review, and you can tell me if it's problematic or not for you. Yeah, so that's kind of generally what it looks like when you try and do a pull request. Is like you wait around, and then like this will probably get merged like maybe in like 2 or 3 months or something. So it's a lot of like sitting and waiting. You don't actually get things like in that quickly, and they shouldn't go in that quickly. This is software that like people are going to be relying on with like billions of dollars. So I am very happy, even though it is like personally depressing. I'm very happy like in the abstract that it should take that long, because like the worst would be if my code were responsible for like somebody losing lots of money. That would would be awful. Luckily, Bitcoin says somewhere in the thing like no warranty or whatever, so you're not going to be responsible if that does happen. Although people may still think you're responsible. You might lose the court of public opinion, but not be in jail. So for testing, as I said earlier, there are 2 kinds of tests. There's these unit tests and there's these functional tests. How many of you use Travis on your GitHub? Anyone? Okay, so you can enable Travis on your fork, and then anytime you push a fork, it's going to like run a bunch of tests on more platforms than you have locally probably. So that's like kind of the easiest way, but nothing beats like the quickness of like just building it locally and seeing if that works, and doing a test if you've got to do a really tight loop. So I would recommend doing local as much as you can, but before you submit it to the rest of the world, you want to like actually test it locally. Writing new tests and reading old ones is good to just understand. Like if you are starting to look at a piece of code and you're going, I don't understand what's going on here, go read the tests, because the tests are going to show you like what that code is supposed to be doing. And they're going to have like simple cases of like, given this, it should do that. Okay, so now, how are we doing on time, by the way? I don't have a clock. 20 minutes. Okay, so we're probably not going to get through everything, but I'm going to talk a little bit about contributing. So there are a lot of different ways to contribute and really be an important member of the Bitcoin community. So you can do documentation. You can have like novel ideas and just kind of put them out into the ether. Not that ether. You can review other people's code and ideas. You can do rigorous testing. Conference and meetup organizing is really important for those in the back. So you can make tools for developers, but you're all here because you want to like conceivably write some new code. So the first thing that you have to do is write good code. Now that's kind of obvious that you have to do that, but it's important to just find an issue that you personally think is important, because it's going to take a lot of effort to like get something in. So you don't want to be doing something because you don't like that you don't care about. So find something that you like. Then write something that you think like solves it. Try your best to document it as clearly as possible, and write some tests that cover the code. And then put a branch of that into your fork. Once you've done that, you've got like something that like somebody else can conceivably look at and use, and like take a peek. So like write a message to someone like me. If you know Matt Corallo, the Blue Matt, Corey Fields, the Uni, Jonas Schnelli. You can kind of treat people like that as like your triage nurse. So you can go and be like, hey, I've got this thing, and either they can help you directly, or they're going to tell you like, oh, don't ask me, ask this person, let me connect you with them. And you want to do that because you don't want to go to the wrong person, and you also don't want to like just kind of like broadcast it out saying I have the best thing ever, because a lot of people have a lot of context for other things going on. You can even talk to them before you've even started working on it, and they'll tell you if it's advisable or not advisable. If you're really not getting feedback, you can go into the Bitcoin Core Dev IRC and say, review this. There's a weekly meeting on Thursdays. You can go and say like, I'm looking for review. I need help with this, and people should be receptive to that. And as I think I've said and will say a lot of times, like you've got to be gracious, and negativity on your work is not negativity on you. Everyone is like happy to have more people, like more eyes on the code base is like why it's secure. So I also think that it's good if you like run a lot of nodes yourself, because then you're going to be able to like get more like experience with like seeing when things go wrong or when like things are like not syncing. Hopefully they're always syncing, but it's good if you have like something that you can always keep on. So like maybe run a different server for this if you can like have something always on in your house. And when you're doing a test of a new feature, compare the debug logs. So say like, well, I had this new node that I made, and this old node, is the new one actually synchronizing as fast as the old one? And if you introduce some regression, you'll get a sense for like, oh, actually, for some reason, I'm no longer connecting to like good peers. What happened? And then you can go and figure out like why your new behavior is not as good. Or if you are beating it, now you'll have evidence to say, hey, I ran this for a month and I synchronized like 10% faster all the time. That would also be good for you having personal assurance of what you're working on is valuable. This is difficult and something that if you haven't like worked on like big open source projects before, or like had like strict practices at your company, you'll get used to. You want to restructure your code changes to be a small set of logical steps that like make sense. So sometimes I've like done a lot of work for like a month, and then I'll take the final commit and then I'll rewrite intermediate commits between it that like had nothing to do with my development process, but I felt were instructive for being small steps. So small step semantics are easy for other reviewers to go through, because what you say is you say, I have this version and I think it's bad for this reason, and I will make one small change and it is still okay, but this is a step towards another thing. And then you'll make another thing, small refactoring, and then you've created these, you've synthesized them from nowhere, right? They're not actually something that you had to do in your development process. And then eventually you get to your end state. What that allows a reviewer to do is they're able to quickly go over the beginning ones and say, yeah, this seems correct, this seems correct, this seems correct. And then only the complexity at the end is what they actually like then spend their cycles on. If you do it all together, they're going to be thinking about all the refactorings that you had to do along the way to get there, and it's going to like make it so that your PR is basically unreviewable and it will almost never get merged. So you have to get comfortable with the idea of like having to rewrite code once you have something that you like. So once you've kind of done that, you've made your fork, you've asked for feedback, you've restructured your stuff so that it's like logically coherent for other people to follow along. Then it's time to like open a pull request on GitHub. So make sure your Travis is passed, because people won't look if it has a red X over it. Then write up a few paragraphs motivating your change, explaining what you did, what types of review you're looking for, what the future work could be that you're not going to do, and like any other detail you can think of. If you want an example, like go look through my PRs, because I try and always do this. Not everyone does it, but it's going to set you up for success if you give like a really clear motivation for what you're working on and why other people should review it and why it's important. And yeah, just at that point, like you can even ask someone like me, like, hey, can you read this PR comment that I'm going to do? And I'll tell you like if there's something that I'd want to know before you open it, if you just want to make sure that it's going to be received well. And then you wait. Review takes time, sometimes months. And when you get feedback, try and respond quickly. Sometimes you can kind of, you'll be busy on something else, but for a reasonably complicated thing, it could take like months or even a year for it to get merged. And that's okay. If you think about it, the release cycle for Bitcoin is every 6 months. So no one's actually going to be using the code in the real world for at least 6 months. So there's no like struggle to get it in, tomorrow, unless you have work that's depending on that getting in faster. So for your first thing, so now you kind of like see this whole picture. For your first thing, I'm going to tell you, like, do something that like you really don't care about. Again, do something like adding a little bit of documentation, adding tests, adding some, fixing a typo or something if you can find one. I write a lot of typos for, I write them so other people can find them. And just go do that, something that you won't care about. It's just going to get you familiar with the actual process of getting something merged, and then you'll get like, that like little badge on GitHub that says you're a contributor to that project, which is, nice. But if it doesn't get merged for whatever reason, you don't care. You spent like 10 minutes figuring it out. So do that, and then, while you're in the middle of that, get started on like your bigger project. Because you don't want to be using something that you're actually proud of as your first learning experience for getting something merged, because then you'll be like upset when it doesn't get merged for like silly reasons for a long time. So I'm not sure I have too much time left, but we'll just do a little bit of general advice on like, existing in the community. There's a bunch of things that are great to read. So like here are all these resources that you can go and just like spend, your afternoons and evenings and days if you're unemployed like me, just going through and like learning lots and lots of stuff. So definitely spend like time here. Maybe controversially now, but like Twitter is also pretty good generally. I think that that's where the good public discourse happens. I would avoid reading like Reddit or like the New York Times or The Economist, because like they don't really know what they're doing, and it's a bit behind on the times. And there's enough stuff in the good to read category that you'll like stay plenty busy. And socialize. Like there's a lot of really cool people in this space. That's actually why it's like fun to be a part of. And I think a big reason why most people who are core developers do it is like they like interacting with these other really awesome developers. So like get to know them. Go to Scaling Bitcoin if you can, or Breaking Bitcoin, or these meetups. Hang out on Twitter. I meet a lot of really cool people that I wouldn't meet otherwise just by tweeting at them. And yeah, try to like, make friends, because if you don't have friends, then you'll get kind of sad on your own. And yeah, I mean, just like, again, I repeat myself a lot because it's important, but you have to be patient. Like it's security software. Like given a choice between like you being a developer and like introducing a bug, like everybody's going to take not introducing a bug. So like if you can't wait for something to get sufficient review, like this may not be rewarding enough for you if it's going to be painful. It's really slow. Like people just constantly nitpick everything about your code. You'll get upset when like somebody finds something that's broken that you spent like the last 30 hours like proving to yourself that it was correct, but it turns out there's like some case you didn't consider. But at the end of the day, like once you have like things that are getting into Bitcoin, like it's really high impact. Like, billions of dollars are relying on that code to be correct, and you can make the system like significantly better by writing a couple clever things. And like that is like a reward in and of itself, but it's long-term gratification. So it's not something that you're going to feel tomorrow. Like I'm a Bitcoin core developer and I've done great things. Like it's going to take a long time for you to reach that point. So I think, there's like a whole other talk in here that we could get into, but I think time-wise, we're limited. So happy to take a couple of questions, and then the rest of this will be online. Yep.
In your experience, do ideas ever flow from other implementations to core, or is it mostly like a one-way street?
So they do. I'm trying to think of a good example. I think if you look at, I'm trying to remember who had it. So I'm probably going to get something wrong, so like somebody will have better references than me, but I think something like segregated witness was originally done inside of Factum. Does anyone have the proper reference on this? Okay, so just believe me. I know like somebody else had something that was like really similar to segregated witness, and then that was known as like a problem in Bitcoin for a while, and so it was like fixed for their protocol, and then segregated witness itself like heavily borrows from the same idea, but almost like that is the only way to fix the problem. Bitcoin Cash is a different way of fixing it, but like that's an example. But even something like that, it's I would say it's not like a I'm trying to think of like what the like set of people who are like really like professors in the space are like people who are core developers who like end up seeing kind of from the top, or maybe from the bottom they see everything up. There's not like a level like lower unless you're like a cryptographer. And it turns out there are cryptographers who are core developers who like understand like, you know, how all the signatures and hashes are working and have improvements for them as well. So I think that's kind of like, yeah, there is a little bit of like, the net flux is definitely outwards.
Well, I guess the reason I'm asking is it would, like I could be higher impact faster on other implementations that I don't know C++ very well. So the question is that worth it, or should I just go straight to learning C++?
Yeah, I would say it's probably, if I were in your position, I would make the investment in learning to be a Bitcoin core dev, because I think you'll probably learn more overall from that community. That's my opinion. There's a lot to learn from Ethereum. There's a lot to learn from Stellar. It's just different things that you'll learn. Generally, I found that the people in the Bitcoin space know the most about other spaces compared to people from other spaces.
Oh, I mean, like even like the Golang Bitcoin, for example.
Oh, so like BTCD,
yeah,
or
like BTCD, yeah.
Or Bcoin, right. The JavaScript one. So there are occasionally interesting things that like they'll do implementation-wise differently from how Bitcoin is done. Generally, it's not because of an awareness issue. It's because Bitcoin is like the first code base, and things were done a certain way, and it takes like effort to like redo them. So yeah, I think that there are actually good learning opportunities if you're working on other implementations, or even it's easy maybe to do your own node from scratch, just synchronizing, not like validating everything, or you know, being a peer on the network, but just like receiving blocks and checking that the longest chain is correct. That can actually be a really good exercise to like make sure you understand all the fundamentals of how it works, but then you don't end up maintaining like the databases and things like that.
Sweet, thanks.
So yeah, you can learn a lot by going in, you know, less mature implementations.
Earlier you mentioned when you were talking about reducing bandwidth, you said something compact. I didn't catch the whole name.
Yeah, so that's compact blocks. That's something made by Matt Corallo. In the slides, which like is going to be available, there's like a whole thing on. Well, it's like these are really long, so I didn't know how much time we're gonna have. There's a whole thing on like what compact blocks is, so you'll be able to read that. It's a good introduction. Basically, all you're doing is saying like, a block is composed of transactions, and every node maintains a list of pending transactions. So instead of sending the block, which has a list of transactions, send the block and a list of like the IDs of which transactions should be in it. And so if you do that instead, then like you end up sending like 10% of the amount of data, and you reconstruct it when you receive that sketch of the block from the transactions that you already have. So that was made by, you know, a lot of work, and ends up significantly reducing the bandwidth because you already have sent the transactions that are in the block. That's all that is.
Okay, thank you.
Do new contributors tend to stick around, or do you have a lot of people who contribute and then leave?
I don't think so. Recently, we've had a couple people coming in who are looking at doing more like PM type work to actually, like, I presume, keep better metrics on how people are getting involved in that way, and if they stick around or not, how, like, what the bounce rate is. I don't know of anyone who has that. What I will say is, like, right now, I think there are more people coming into Core per day than like I've ever seen before. I don't know. It's just like you can. There are currently about like 40 people who are would be kind of considered core developers, more so than just a contributor who's contributed once. Like people who are like kind of actively involved. It's maybe about 40 people. and they've been around for a while for the most part, but new people come in pretty often. And I think once you make it into the set of people who are kind of considered active, you end up staying for a while. But I don't know exactly how many. I just know that like recently I've seen a very big uptick in the number of people who are actually trying and making pretty good effort.
Do you think there's enough work for people doing things like documentation or more general, I wouldn't say janitorial since that had a different context here, but cleanup work in the overall code base to keep somebody invested in the project for a long time?
So you mean like if somebody just wants to do documentation type stuff? There definitely is. I think also if that is your like preference for working on that kind of stuff, there's a lot of things that need to be done in the usability direction of there, as far as I know, and I could be wrong, nobody has ever done a usability study on Bitcoin Core. Never. And that isn't like great. Dan in the back might know. Have you done a usability study on Bitcoin Core wallet? Okay, so no one's ever done it. I have a question, like how would somebody who like, you know, doesn't have hands, let's say, how would they use Bitcoin Core? Like, I want them to be able to use it. It's not my expertise to be able to you know, figure that out. No one's ever tried. And I think that like making it much more accessible is something that fits in with documentation. And like, I think you can find like endless things to do in the side of documentation of like, hey, how do you make Bitcoin compatible with screen readers? Like, I haven't seen anyone do that yet, but there are people who spend time on that. And so I think you'll, you know, find a lot of work cut out for you if you want to do documentation.
Cool. Thank you.
Thanks. Another question is more of a fun question, I guess. What was the most surprising thing you found out about the code base or the process compared to your expectations before you came in? You have kind of an image of this project, obviously an extremely important one. Then you come in and you discover something that shocks you. I'm sure there was something like that.
So it's changed a lot over the years, and I think that like my initial shocks would like be less true now, but like kind of part of it is like how bad the code base is. Like you look at it and you go like, huh, the way that like this is done is just weird. Like what was Satoshi thinking when Satoshi wrote that? And it's like, well, I don't know. He was just trying to get it done. So he got it done and he launched it. Like he obviously succeeded. So like who am I to judge, right? But then that's what is fun about it, because you go, this thing is like obviously wrong. Whoever did this needs to be like taken out back and shot. And then you're like,
This is why
well,
no one's coming up and saying they're Satoshi, because everyone wants to shoot him.
yeah. Well, then you fix it, right? So like that's what's nice about being, you know, there's obviously like lots of work cut out. So like that's where like sometimes I'll go, and especially for performance related things, you'll look at a line of code, you'll go, like, if you wanted to write a slower way of doing this, like you couldn't. And then you'll go, okay, well, like now I'm going to write the fast way. And you know, to be totally fair, like if I were writing the code for the first time ever, and anyone had ever written that code, right, I probably would have written the slow one too. But you know, hindsight 2020.
Kind of actually a follow-up on that. So let's say take your example where you try to whitelist RPC calls, right? It seems like it would be useful for Litecoin and Dash and others as well. So how or would you actually sort of submit that to the other projects as well?
I probably would not submit it to them. If they are regularly downstreaming patches, then they can get it themselves. If they want to like pay me, I'm unemployed. Like they can, you know, like give me some money and I'll get it in there for them. But no, in general, I'm just gonna put it into Bitcoin. And yeah, it would be useful for them too. Like everyone should maybe have it. But there are a lot of things that are like good in Bitcoin that like maybe everyone should have that they haven't yet, you know, taken, because it's really difficult to like rebase a whole code base. Like Zcash runs on like, I think this is the case. They run on like Bitcoin like 0.12 versus like the latest one, which is like 16 or something like that. So like they could be running with like lots of new features, but like it's really hard to like take everything they've done on top of like Bitcoin 0.12 and move it over. So they might not ever do that.
You touched on something a couple of times about currently being unemployed. Blockstream aside, what would you say the primary incentive for people to contribute to the code base is?
I would say that like the set of incentives are like it's similar to being a professor, right? Like what's the incentive for being a professor? I don't know. You want to do it, right? Like economically, like there are much better pathways for someone with that ability. Like time-wise, lifestyle-wise, there are also better pathways. But you want to do it because you want to teach people, or you want to have an impact on this thing. You care about Bitcoin. You care about the mission. So that's ultimately the incentive. There definitely could be like much more money flowing into core development than there is right now. And I know that there are a lot of people who are working on that, but it's one of those things where it's like the number of contributors who could be working full time on this is growing much faster than anyone's allocating capital into people working on core development. I think part of it is because people underestimate how critical it is for this like stuff actually making it. Like, I would say like right now it's like, someone who's like spending a lot of time thinking about what furniture is going to go in the space capsule versus like thinking about like, hey, are we sure our rockets aren't going to blow up on the launch pad? Like, we need to do a lot more to like make sure these networks are like really hardy and really distributed and like actually going to work. And that's like a lot of effort. But right now people are focused, I think, a little bit more on the like, what's the furniture going to look like problems? What color is the rocket ship?
Isn't that question of motivation one of the things that differentiates people who contribute to Bitcoin Core versus a lot of other projects? Right, because like Bitcoin didn't get ICO'd, right? So
yeah,
it feels like it's a very different incentive structure because people are more driven by like internal motivations, intrinsic, not extrinsic.
So I won't name and shame with this one, but one of the most important Bitcoin Core developers told me that he once had like $1 million on Mt. Gox, but it was cash. not Bitcoin, and then it like was lost, and now he has like no Bitcoin, but he still works on it. So like for most people, it's like it's not like everyone kind of theorizes like, oh well, like the network should be incentivized because everybody has some Bitcoin and they think it's going to make them wealthy if they make it more more performant in some way. That's definitely true for some people, but not for everyone. There's a lot of people who just do it because they find it gratifying for like other reasons. So yeah, there's no like. Definitely there's, altruism or like selection bias for people who are like stupid in the way that they like decide to spend their time on that.
Well, questions?
I guess given the disparity between, say, like money invested in outside of Blockstream, like to support the lifestyle of open source devs versus just the the furniture on the spaceship projects, with the amount of time you spent around this stuff, what do you feel like breaks that trend? Because obviously it's not going to last, but is there any sort of like event or thing that you see that will come up and kind of break the current trend of just money flowing into nonsense?
Probably not. I mean, one of the things to like stick in the metaphor and really like, I love bad analogies, but like, when you decide that you need like these expensive Italian leather sofas in your like spaceship that like weigh like 1,000 pounds, like you realize like, hey, you need to make it cheaper to send heavy things. So I've definitely heard people theorize that like in order to like attribute enough capital to like these like commons, like people are only willing to allocate like 0.1%. So you need to have like $1 trillion industry to put enough capital into like the bottom layers, and so that's like an upwards pressure on like the stupid shit that like people put money into, because they make some small like accidental basically investment in the base layers. I think that will be a part of it. I don't like that version of it. I think that we can do better if we like have some more like personal responsibility for these things, but we'll see where how it evolves. Things are going in a better direction right now than previously.
All right, last question. Okay, 2 last questions.
No, you were first. Okay. So for that analogy you were just talking about, can you give a more concrete example? Like, what is the sofa in Bitcoin Core?
Sure. So, for example, there has been a lot of money spent on like colored coins, if you're familiar with those, like tagging an asset. And that's like cool stuff, and that was like, this is a while ago, so it's maybe not the most recent example, but there have been a couple companies that have like raised like reasonable amounts, like probably more than has been like directly invested in Bitcoin core development for those companies, and like they've all kind of failed because like the stuff doesn't scale well enough. I think that that's like maybe a reasonable example. It's not as bad in Bitcoin. Like, you know, my like, if I can take my maximalist hat and put it on, like Ethereum, like we put all this money into, you know, Ethereum, and like it's all these like amazing applications that like are never going to work in that decentralized environment unless they figure out like all these other hard problems. And so until like, you know, that happens, like it's kind of all for all, like we don't even have the rocket ship yet. So like I think that that's like the, internally it's not as bad. Externally, like, you know, if you look at the Bitcoin dominance index, like everything else is to a certain extent frothy, like unproven, not necessary. I think the things that are important are like more research on like consensus. You know, my disclaimer, like I am an advisor to Stellar. I advise them because I think like having more like diversity in consensus algorithms is actually like good. Because that's like a base layer, like that's the rocket ship that we're all riding up, right? I think other things like that are like the basic crypto, like, you know, what is a transaction? Like, how are we doing signatures? Do we, you know, what's our privacy like in these things? Those are all kind of basic things that need the investment more so than like, you know, the crypto kitties or something like that.
Yeah.
Hey, on the privacy side, what kind of ideas are being worked on?
There's actually a lot of really cool stuff in privacy right now. So one of the recent like really fundamental breakthroughs is something called bulletproofs. Bulletproofs are a way of doing what's called a range proof. This has an application in something called confidential transactions. This is where you mask all the amounts that are being sent in a transaction, so it just looks like noise. So you'd be able to see who sent, you'd be able to see who got, but you wouldn't be able to see how much they sent or how much they got. This is not as strong as something like Zcash, but it is much higher performance in terms of like needed bandwidth. So that's one of the really major things. Bulletproofs make it actually like usable. One of the other major things happening right now is something called Taproot and Graftroot, which enable kind of fancy smart contracts in Bitcoin without like loss of privacy over what those fancy smart contracts were. All these things will typically be, so I'm really not sure that like something like bulletproofs will actually make its way into Bitcoin because it's a complicated change. But for the most part, like you can always just tell someone like, here's how much money I was transacting. Like nothing stops you from publishing it anyways, even if it were mandatory to use it. Like even in Zcash, like I can prove to you what my transaction was. So all these things are always kind of optional. Unless you have like strong deniability in your crypto, then like no one might believe you. But you might be able to prove that you can't have deniable transactions. That I don't have a proof for that, but like, yeah, I think if you did, then you could falsify things. So I don't know. To be determined.
All right. That was the last question. Thank you guys so much for coming. Thank you, Jeremy. This was awesome.
Thank you for having me.
Hope you can stick around with us. So for